we are going to go ahead and get started with today's CAM Skills event. What we're doing is called Useful Tools for Your Manufacturing Needs. I'm Adam Bordelon. This is my colleague, Sherman Snyder. He's on the tech support side, so he's going to do most of the presenting today. But today is a little bit different. We're going to have some videos playing, but we're also going to be looking at several different modules and seats of Mastercam. And we just want everybody to get a quick look at what's available, just in case there's some tools that you may need that you're not aware of that'll help make you more productive. And we're just going to start off with the Mill-2D seat. Some of you may have it, some of you may be looking at it. So Sherman, please tell us about Mill-2D.
All right, and as Adam said, moving forward, some of you may be pretty familiar with some of these packages and add-ons that we have available for Mastercam. Depending on your experience, we're going to go ahead and start with the Mill-2D side. And of course, when I talk about the Mill-2D side, I typically think of your basic toolpaths, such as your contour toolpaths, drilling toolpaths, any kind of tapping or reaming cycles you may encounter within Mastercam. But we also have the ability to do other operations within the 2D package, such as what we see here in the video. We're doing a pocket operation. And as you can see from the actual toolpath itself, we're utilizing the dynamic motions that Mastercam has to offer. Within the 2D package, you'll also see your dynamic toolpath, and these type of toolpaths and these type of motions within Mastercam will allow you to take advantage of the radial chip thinning that these toolpaths have to deliver. You also, with these toolpaths, will see more extended tool life, being that you're taking more of the blade of your end mills instead of just the tip. We also have that opportunity to maximize the metal removal rate with these toolpaths and reduce your cycle times as well. With the radial chip thinning, you're going to see higher feed rates, where your typical contour toolpaths, you may see your standard slower feed rates like you would in the past. So, as we see here, we also have our hole operations as well. We have the ability to sort our holes depending on how we select them. We can select our tools, different type of operations, and then we have a basic rundown of our linking parameters here within Mastercam, showing your clearances, your retracts, and of course your top apart and the depth that you want to drill. So a lot of these toolpaths that you'll see on the 2D side, it's going to be very familiar from one page to the next, even if you're drilling to milling. So you'll find it very familiar as far as working within Mastercam here. So.
Yeah, so notice you certainly start at the top, work down the page, fill in the information, and you're going to get a good toolpath.
Absolutely.
So with that said, Mill-2D certainly is very capable, but it comes up that some parts are just more complicated than others, obviously, and when you start getting into, say, multiple surfaces, multiple axes, and that sort of thing, or you just need a little bit more, let's say, different performance, Mill-3D may be the answer. A seat of Mill-3D may be more productive and more cost-effective for you. So we'll do that next. Sherman's going to tell you a little bit more about Mill-3D and what makes it unique and advantageous.
Okay, so taking a look at the Mill-3D side, what you can see here is a basic contour toolpath that we have going around our part, chasing the profile of this part. The 2D side of Mastercam gives you that ability to utilize all three axes at one time. But the problem in this case, what we see is with the difference between our contour and our OptiRough, I can actually take advantage of the full solid of my part. So whenever we jump off into the Mill-3D side, we can utilize the solids and reduce that cycle time that it takes to cut what we've seen here for the profile versus what we actually have here for the full 3D operation. The 3D mill side of Mastercam will allow you to read these complex surfaces, and again, you could still take advantage of the dynamic motions that Mastercam has to offer. In this case, we were using a OptiRough operation. Within these operations, you can also add different stock allowances to different surfaces as well. So unlike the standard 2D package where you're kind of locked into what you want to leave for your stock and wall, OptiRough, whenever you're roughing out, I can actually leave different stock on different surfaces on this part and have a little bit more control over what I want to leave for my finish operations.
So these toolpaths, you could say, it's not only easier to create the tool paths than create a finished part, but your program in the end is probably better too.
Yeah,
more efficient program,
definitely.
more efficient programming.
Yeah, so in an instance like the part that we're looking at here, if I wanted to rough out the center cavity there, or between the, right down the center, I would have to actually create geometry to cut down. Where the profile is pretty straightforward, I can cut the profile completely, around, because I have just a straight wall. But now in the center, what we see here on this cutout, for me to try to read that surface, OptiRough right off the bat is doing it all in one shot. It's taking advantage of the OD, or it's taking the OD out, or the outside parameter and the inside as well. Where 2D, I would actually have to have geometry laid out. I mean, it gets a lot more complex, and at the same time,
and those hours add up in programming.
Yeah,
so
definitely add up. And what you see here for the stock that's left behind under our stock model, within Mastercam, I can actually take larger depths and utilize that dynamic motion. And then after I'm done, actually step up and take shorter steps to get a better finish as well. So instead of starting from the outside every single time and stepping down to get that small scallop height, we can actually take large steps and then work our way up and reduce that cycle time as well.
Good deal.
What you'll also see under the 3D side is more advanced features such as your surface milling, where your 2D package only allows for single surfaces to be selected. And you do have some very minimal surface milling capabilities within the 2D side, or stitching, depending on where you're located in the U.S. But we could take advantage of the multiple surface side and read those complex surfaces, as said before. So,
that looks good. And with that said, even with all that capability, sometimes there's still more, especially if you start talking about more complex shapes and the equipment too. 5-axis machines, I would say mostly. We offer a Multiaxis add-on, which would be, this would be features you add to Mill 3D. So why don't you tell us a little bit about Multiaxis and where we can take advantage of that package or that offering?
Absolutely. So when it comes to the Multiaxis package, as we can see here, I have a nice surface mill toolpath. And what we're going to do for the Multiaxis, in this case, we could take advantage of the tilt axis that we're allowed inside of Mastercam. When it comes to the Multiaxis side, we also have advanced gouge checking. So I can check my tool paths against certain features such as my holder or my shank of my tool. And when I run into any instances where my tool might be actually gouging into the material, I can tell Mastercam to either rethink the tool path or retrack. So you definitely get a lot more features as far as collision checking capabilities just on the Multiaxis side.
And when you say collision checking, we're talking about the cutter itself, the part, work holding?
Yes, work holding as well.
The machine itself?
Yep.
The table, the spindle?
Absolutely. So whenever, when I think about Multiaxis, I also think of machine simulation. One of the biggest things whenever you're working within Mastercam, in this case you see this part, I can actually verify or backplot my toolpath, and it's going to sweep from one side to the next just fine. What you don't see on the simulation side is when we actually get to the center of this, the table rotates. So not only are we taking advantage of those simple gouge checking capabilities, or the more advanced ones actually in this case, but when you compile this with the machine simulation, you get the full-blown environment, and you can actually see everything that's actually happening on the machine. But also with the multi-axis side, we start working with, say, 5-axis safety zones, where I can utilize my stock around my part, or I can create a cylinder about my part to make sure that my tool stays within the safety zone as this part's rotating around. At the end of the day, when it comes to, say, your simple 3+2 operations, it's all about clearance, and you want to make sure that you're clearing your part. When we start looking at the multi-axis side, in most cases, a lot of times people have the tendency to think, well, we're doing full 5-axis capabilities, and you do have those options. That's what this is all about. But I also bring up the fact that we could take advantage of these more advanced options, advanced tool paths that we have, and make them a simple 3D or a simple 3-axis operation as well, or a 4-axis operation.
So this is not machine specific. I don't need the highest end, highest tech machine. This software can help with just about any mill, really.
Correct. So if we have, say, a Haas vertical with an A-axis on the end, I can still use my morph capabilities that you'll see inside of the multi-axis operations.
Okay.
And as we see here on the screen, this is one toolpath where you can see we actually have our accelerated finishing toolpaths within Mastercam as well. So typically when you look at the 3D side, we can actually use the tip of that ball mill to do a simple surface pass. When it comes to the multi-axis side, we have these abilities such as accelerated finishing that will allow you to use form tools such as barrel mills, taper mills, any kind of lens cutters and stuff like that. And as we can see here, the finished tool path is actually going to give you a lot larger step over and still give you just as fine as a finish as you would taking smaller step overs with the tip of a ball mill. So,
and those tools you mentioned for folks that may not be running 5-axis already, those are special, but they are available for purchase. It's not some custom tool, right? This is a tool path to take advantage of tools that exist on the market.
Correct. So these are typical tools that you'll find on the market all day long.
Right.
So, and this isn't something that you have to like custom draw within Mastercam. These are standard tools that you can create too. So you have the options under your tooling manager to be able to just simply create something like this here. We have our taper tools.
Got it. All right. With that said, I think we got a decent little look at milling some of the seats and the add-on. But let's shift gears just a little bit and take a look at the lathe and what a basic seat of lathe is going to get us and what it can do.
Okay. So, and before we step forward, one thing I do want to mention as well is the multi-axis side. You can also find this in, not just the 3 or 4 axis, but you can also find this for your routers as well.
Oh, right.
So that's definitely a good point. But as mentioned, as Adam mentioned here, we're going to talk about the lathe side. And what you typically find in the lathe side, we're going to be looking at this nice little pond here. You'll see your standard roughing operations, your grooving operations, threading, parting off, any kind of drilling or boring operations that you typically have on your standard lathe that you would run across. One thing Mastercam does allow for is you have the options to choose between, like in this case, what you see here for your setup, we can do pie jaws, we can do your standard chuck jaws, but we also have those options for long hand code and short hand code when it comes to the cycle side. Within Mastercam, we also have certain abilities for 3D tools. If we have any custom tools that we may have modified for clearance issues, whether on purpose or not, we can actually model these tools and import those inside of Mastercam.
And we don't necessarily have to model them. We can get them from the manufacturer, right?
Correct.
Easy to do?
Yeah, absolutely. Me personally, I like using things like, say, the tool reps or the tooling company's actual pages. A lot of them have STL files you can bring in or step files.
And this is the holder, the insert, the whole deal.
Absolutely. We also have, as we see here, the ability to use custom thread cycles. Like here we have a rope style thread. We can actually use a button tool and cut these custom form threads as well and save these operations that you see here for later templates as well if you run them across multiple parts. So again, kind of reiterating what I said before, we have those options between long hand code, can cycles if you prefer can cycles on your machine. We could save these tool libraries, and at the end of the day, we want to take these tools that we see here, and as you can see, I have drills, I have my standard CNMG turning tools. I don't have to recreate these once they're created. I can save them, and as you see here, I got my 3D tools. I can bring these back into any kind of tool or any kind of new operations that I'm doing. So definitely saves a lot of time, and as you can see here,
you get plenty of detail on those types. So.
Yeah, definitely see a lot more detail.
All right, good deal. Well, I think that gives you a good idea about the lathe. Of course, you can see there's quite a few tool paths there, so Like with anything, if you want to know more about it, let us know. We can set up a demo and that sort of thing. But let's try to put lathe and mill together and look at the mill-turn machines and the environments and some of the features mill-turn offers.
Okay, so right off the bat, whenever we're looking at the mill-turn side of things, we want to know the differences between the mill-turn and the lathe side. And one thing I didn't mention when we talk about the standard lathe is we actually have the options for C and Y axis milling too.
Right.
So as far as the mill-turn side, what this gives us the ability to do is not only have sync codes from one spindle to the next, where I can sync my spindles. Say if you're doing like pinch turning between an upper and lower turret, we can actually sync these together to where one may cut at the same time as the other, or in most cases where you're leading with one tool and cutting behind it. But what you also see in the mill-turn environment here is we have the full machine simulation. Instead of your standard post processors that you'll see for your lathe side, we actually deliver this as a machine environment that actually it's going to have your full machine simulation as we see here, and give you that ability to not only sync your spindles from left to right. As we see here, we have weight codes and, of course, our tool kind of running through our chuck. But we have that ability to make one spindle and to the other wait for one another, but the turrets as well. So
right. And then the previous side, you listed quite a few machines. So this is because some machines are going to have maybe 2 turrets, 2 chucks, maybe not, milling head, and that sort of thing. So different features. So when we deliver an environment, it's specific to the machine, right?
Correct. So each one of these machines is going to be definitely specific to it, whether you have, say, dual turrets or dual spindles. We also deliver this in single stream environments as well. So just because you don't have a B-axis head doesn't mean that you can't take advantage of what you see here, we call the IOF. It's going to allow you to see that dual sync there between in this case, what we have going on with the tools changing back and forth, we can actually put weight codes in there. At the end of the day, what you're going to see here is exactly what you're going to see on your machine. We have the virtual prove-out program with the weight codes that we see going on right here. We can identify any kind of collisions as well. So
yeah, I see the red popping up every once in a while in the example. So that means I need to take another look, whether it's my machine hitting my chuck or my tool hitting my part, one or the other, it's going to show me.
Absolutely. So, and at the end of the day, like I tell anybody, it's always best to check twice, cut once. It's definitely a lot easier to remove the material than put it back. But at the end of the day, the simulation here is going to make you feel a lot safer when you're actually running something. These machines are very expensive and very complex. So
pretty involved, a lot going on. So
the last thing you want to do is have to have a machine down for a week or two to wait for a spindle to be replaced.
Sure.
So
okay, so I think that gives us a pretty good idea of what's going on with mill-turn. So we're going to switch a little bit. We're going to look a little bit more at mill again, except rather than sort of a standard mill seat like we already covered, we're going to cover something that's a little bit more special. If you're doing blades and impellers and that sort of thing, we offer an add-on called Blade Expert that's really useful. It's a very smart tool that's designed to make these types of things a little bit easier, more efficient programs, and more efficiently creating the program itself. Like we talked about before, we can make the program more efficient when we cut, but also generating the program is a little bit more friendly as well. So
Absolutely.
Tell us about Blade Expert.
It's going to take these 5-axis challenges that are usually a lot of operations and kind of streamline them into a quick template. So in this case, what we'll see with the Blade Expert, you'll have your maybe remove material between blades, like we see here, finishing the blades and the splinters afterwards, finishing the floor, and then finishing all the fillets and everything to kind of streamline things. But now what we see here in the operation is right off the bat, you got a nice little picture, and again, you see the roughing types that we have. But one thing you'll notice is that the interface for this is going to match the interface for a lot of the multi-axis toolpaths. Just as we talked about for the 2D milling, the multi-axis side will pretty much mirror the same thing. This makes that learning curve that you'll see between your standard multi-axis operations to the Blade Expert minute.
Right.
So it
Seems like across the ribbon and down the menu is what I need to do.
Exactly. So. And it's going to make that deployment of, say, if you're taking the multi-axis toolpaths like morph and everything else, it's going to make the deployment of this add-on a lot easier on the user end as well. So,
right.
But again, what this is going to do is give you, instead of taking all those toolpaths and building a lot of geometry, this turns it into routines. And again, kind of fast paces everything for you.
Yeah. And I think, speaking of fast pace, I know we're running through these pretty quickly, so I just wanted to say again, if this piques your interest at all, let us know so we can set up a more formal demo. Today we're not trying to hold everybody up all day, so this is more to just give you a very quick peek of what's going on with this stuff. So please do ask questions when we get to the end. Give us a call or set up a demo, whatever we need to do to make sure if these tools are useful to you, that we can show them to you a little bit more. And I think with that said, we're probably ready to move on to Port Expert.
Absolutely. And real quick, what we see here is kind of the view for our machine simulation. Mm-hmm. So you can kind of start seeing where some of these packages really take advantage of stuff like that.
And again, this is machine specific. So this is, we can set Blade Expert to work up with your exact machine environment, and everything just meshes together really well. So with that said, now we really are ready for Port Expert, and we'll move on to this. And again, this similar to Blade Expert, this is it's an add-on tool that's fairly purpose specific, but it does its job really well. So let's take a look.
What we see here is, you can see we have the different operation types as well. The tabs that you'll find here look a little bit different, but it still kind of follows the same user interface. But again, this is another add-on that kind of streamlines everything and makes these into more routines whenever you're doing an operation like this. A lot of things preset. There's not a lot of details that you need to go in there and kind of tweak to make something happen. So,
and I can import major manufacturers' tools here as well.
Correct.
Right?
Yeah, you can still take advantage of the manufacturer's tools, import them in. For something like this, you'll also see that a lot of these tools are pretty standard for what you'll find within Mastercam. And again, you can save these to libraries, use them later. But as you can see here in the video, we actually have that ability to change that output from 3, 4, and 5 axis as well. So again, this isn't something that's just locked into multi-axis. These are add-ons that you can use for your simple 3+2 operations as well. And again, kind of jumping back to what I said for the multi-axis stuff, you can use this for your 3D mill and router, 3D routers. So.
All right, sounds good. It definitely has some useful tools, and we're going to shift gears again. I know we're moving quick, but with that said, rather than look at more programming directly, we're going to look at checking parts, setting up parts, measuring, and even reverse engineering. So we have several options there to probe parts inside the machine, outside the machine, scan a part with something like the arm you see here, to build a model ahead of manufacturing and that sort of thing. So once again, Sherman, take it away. What are some add-ons we have available to help with that sort of thing?
So there's going to be a few add-ons that we do have available for this. We start looking at the inspection side first. We do have the ability to probe parts within Mastercam. As we see here, go ahead and kind of rotate this around a little bit. When it comes to the ability for probing, we can do fixture offsets. I can do tooling offsets as well. Program orientation. So if you want to actually orientate this part on your machine for your C axis or A axis, we can probe the part and actually have it rotate around the way it needs to be. But we also have the ability to do report for critical dimensions and tolerances, as well as adjust your machine. So let's say that...
So quick question though. When I probe this for orientation, I probe it and then I have manual inputs, or can the machine...
The machine's going to update those inputs.
By itself?
Correct. So in this case, let's say we're doing this bore here, and my end mill comes down, mills the bore. I can then come back in and actually probe that ID and have my machine update to whatever setting it needs to be to mill this on side. So it can change your cutter compensation for diameter. and amongst other features as well. You have that ability to have these updates before the programs run, mid-program, and after as well. So
for setup and inspection.
correct. So this is going to help with, again, verification of those critical features within Mastercam. One good thing about the probing cycles or the probing add-ons that we do have, there are a couple of them. You can actually run these through backplot and verify as well, and actually see the probe being done. So, unlike how I done it, way back in the day, where we actually wrote these macros, went out to the machine, and actually verified them live, Mastercam is going to give you these abilities to see things before we actually go out to the machine. There are predefined probing cycles that say we're using a Renishaw probe that are going to be default to that company, and machine specific as well. So you're going to have to look at certain things like your machine controls if you're using a Haas, and if you're using like a Gen 1 or Gen 2. So, but these cycles are built predefined, so they do come along with this package altogether. So it's not like you're having to go back in there and write macros and stuff yourself. So. All right, and as we see here, we can actually see it in the back plot, the tool coming down, actually probing that pocket. Now, when it comes to the other side of things here, we do have what we see here on the table, our Mastercam 3D gauge. This is the reverse engineering side of things. We can also use this for inspection capabilities. As we see here, I got my little part. Now, we can actually see the multiple surfaces as we look at this particular part file here. One thing you'll find it's kind of like a three-step inspection process whenever I think about it. You have your part alignment, your inspect, and then you get a report, and that's just for the inspection side. When it comes to the reverse engineering side, I still think about it kind of like a three-step reverse engineering process. We'll have our measure. We can contact any kind of 2D or 3D surfaces and create a STL model off of this. What's going to happen whenever we're doing anything like this, and we can look at our video kind of like what we see here. This is going to be our probe coming down and actually touching off the part.
Yeah. You see the probe in this example. We'll be talking about the 3D scanner too. You'd replace this touch probe with I guess a light or laser type scanner if you want to do it touchless.
Correct. So the part that we actually have on the screen here is the one that we have on the table. And as we probe over this part surface here, you can see these cloud points that are being created. And these cloud points can later be turned into any kind of surfaces or solid models in order to reverse engineer a full part that you need. And again, this can be an STL or it can be a 3D model as well afterwards. So what we see here is we're actually taking these points and we're going to create a surface based off of these points and split our model in order to get the same model we have here on the table. As Adam mentioned, we do have the ability to get rid of the probe here and actually have a 3D scanner attached to this, making it a little bit easier to actually scan something like this instead of probe along. But yeah, it's pretty cool. I definitely like what you see here. You see that surface?
Now you can make one of these.
Yeah.